Hi, this is Mrs. Rodriguez with another lesson video. Today we're looking at terminating and repeating decimals. Okay, so terminating decimal are decimal numbers that have a finite number of digits. Okay, here's an example. 1/2 equals 0.5. The decimal is 0.5 and then it stops. It has a limited number of digits, right? It doesn't go on forever. Finite means that there's an end. Infinite would mean it goes on forever. So this is a terminating decimal because, as you can see, we get a decimal answer that stops after the 5. Okay. On the other hand, a repeating decimal is a decimal number where the digits continue infinitely, meaning forever. So here's an example, 2/9. Well, if I were to divide 2 by 9, we get 0.222222222, and it goes on forever. So that is a repeating decimal because the remainder keeps repeating. It never ends. Okay, and we write that by putting this infinity bar above the decimal that repeats. So in this case, the 2 repeats, so the infinity bar goes above the 2. All right, let's take a look at a couple of more examples. Do the decimal equivalents of the numbers below terminate or repeat? So once again, we're given a decimal number. The decimal stops at 5. It doesn't keep going on forever, so that would definitely be a terminating decimal. And remember, the word terminate means to stop. Okay, so it stops at the 5. It's terminating. All right, B, we have 0.6 and we have this infinity bar over the 6, which means that 6 goes on forever. It just keeps repeating itself. So if it keeps repeating itself forever, this is definitely a repeating decimal. What if we're given a fraction, 5/6? Well, you need to remember that that fraction bar also means to divide. Okay, so yes, you could read it as 5/6, or you could read it as 5 divided by 6. Now, 5 is our top dog. So that means 5 will go in the house and 6 is on the outside. 6 is bigger than 5, so it does not go into 5, and I'm going to put a 0. We still need to divide though, so I'm going to have to add a decimal so that I can add zeros. All right, so 6 goes into 50 8 times, and that is 48. I subtract, and I get a remainder of 2. I drop down another 0. 6 goes into 20 3 times, and that's 18. 20 minus 18 is 2. Drop down another 0 because we still have a remainder. 6 goes into 20 3 times. That's 18. We subtract, we get 2. You will notice a pattern. After we did the how many times does 60 go into 50, right, the 8 times, now we keep getting 2 as the remainder. And as long as we keep getting 2 as a remainder and we drop down zeros, we're going to keep getting 20. And 6 only goes into 20 3 times. So that means this 3 is going to keep repeating. So our answer to this problem will be 0.8, 3, and the 3 repeats on forever, so the infinity bar goes on top of the 3. And since it repeats forever, this is definitely a repeating decimal. Okay, let's try another one. Now we have 4/5. Once again, 4 is our top dog, and the top dog always goes in the house. Okay. 5 doesn't go into 4, so that's 0 times. So we need to add our decimal. So we can add a 0. 5 does go into 40 8 times. I subtract And look at this, no remainder. We get to stop, it ends. So that means my answer is going to be 0.8. Nothing repeats. So this is definitely a terminating decimal, because we can stop at the 8 because there's no more remainder. Okay, and if you're still a little fuzzy on how to change fractions into decimals, how to divide the numerator or your top dog by the denominator, the bottom number, please go ahead and look at the lesson video of how to convert or change fractions into decimals. But there you have it. Terminating decimals end with no more remainder. Repeating decimals, the remainder keeps going forever and repeating itself. Okay? And we use the infinity bar over the decimal that repeats as a way of showing that it's a repeating decimal. Okay, and as always, if you have any questions or need additional information, feel free to schedule an appointment with me for office hours. Hope you have a great day. Bye.